Hello everyone, welcome to the third video on this organic chemistry series. Today we'll be talking about isomers and the importance of structural formula. If you remember, in the past videos we have discussed about structural theory, how it came up and how it has helped scientists. Now this is an important extension as to how it helped further, and isomerism is a concept that will teach you guys the importance of structural formula as well. In our nature we find a lot of compounds, and some of the compounds have similar molecular formula. What this means is that when you take a mole of them, their molecular weight is same. Their molecular formula is same as well. So you would expect two compounds with the same formula, same molecular weight to act in the same way. But they don't. They are completely different sometimes. What makes them different? Anyways, before we get into the what of it, we'll discuss about this phenomenon. This phenomenon is called isomerism. Isomerism exists in different compounds with the same molecular formula. So over time, people were aghast that they couldn't find a solution to this problem. But after structural theory came up, people better understood why it happened. So two compounds behaving this way are said to be isomeric. Moving ahead, a classical case of ethyl alcohol versus dimethyl ether. Over here in this example, what we observe is that one is an alcohol, the other one is an ether. But one is a gas, the other is a liquid at room temperature. Even though they have the same molecular formula, they have highly different boiling points. So what is exactly causing the difference? Our structural theory suggests that the structure of these elements is entirely different. Because of this difference, we have different structural formulas, and because these structural formulas are different, we have different properties altogether. So moving ahead, how are you going to explain the case of ethyl alcohol and dimethyl ether? Let me talk about ethyl alcohol first. Ethyl alcohol has a CCO linkage. As you can see in the slide, we have a carbon bonding with carbon and further the carbon bonding with oxygen. And there are several hydrogen atoms over here, but you can see that one of the hydrogen atom is bonded to the oxygen, whereas remaining are bonded to hydrogen. Moving ahead, we have dimethyl ether and we have a COC linkage, and none of the hydrogen atoms are linked to oxygen, whereas all the hydrogen atoms are bonded to carbon atoms. So there is a case of what we call hydrogen bonding in the ethyl alcohol. We'll be covering this in further videos. For now, just understand that the hydrogen bonding that exists in ethyl alcohol, also known as ethanol, is the reason why ethanol is a liquid, and the absence of hydrogen bonding is the reason why dimethyl ether is a gas. And this case is a classical constitutional isomerism. So these compounds have same molecular formula, but the only difference is their connectivity. How the sequence in which they are bonded is what makes the difference over here. Lastly, we'll also discuss the shape of methane. So after the work of Butlerov and Kekulé, Jacobus Henricus van Hoff and Joseph Achille Lebel proposed that the arrangement of the 4 carbon atoms of methane are positioned in such a way that they point towards the corners of a rectangular tetrahedron. And that's it for this video. Thank you.